Hey everybody, this is Larry. This is me going over weekly contest 204, Q3, minimum number of days to disconnect island. So this was a tricky problem. I mean, as you can tell, even now, about an hour in, only 25 people got it accepted during the contest. So this one, if you watch my video, which I will have later of me live during the contest, it's just a really hard problem, right? Or not really hard, but like hard to convince yourself what is correct. And I had a silly mistake which you can see during the video. But the idea here is just this problem is less interviewee, to be honest, if you ask me, but also it's more of a pen and paper problem. And what I mean by that is that the code is pretty straightforward, or like has nothing that you don't, wouldn't already have if you practiced enough. Like I think the code is actually just like connect the component, or depth first search, connect the component, like very standard things that you'll see even on an easier medium. But the thing that makes this problem hard, and what I struggle with as well, is kind of figuring out how to solve it, which, okay, fine. But so very naively, the first thing that I noticed, and this took a little bit of time, so it's not immediately. The first thing I noticed is that to disconnect one, at worst you could do 4, right? Like so yeah. Let me draw some ASCII art. But my idea was that, okay, so let's say you have something like this, and you want to disconnect this thing. You at first it's gonna be 4 because you go bam, 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 right? But then if you think about it more, in this case where this happens, you just remove the 1, and then this will be disconnected. So that's kind of one observation, is that so now we probably reduce the we probably reduce the space, and there's a special case version of this where you put a corner or whatever. But now we reduce the maximum answer to 4. So 4 is the maximum answer, and then because of this, I wouldn't say it's a proof. It's a little bit hand wavy, to be honest. But because of this, you can reduce the answer to the max answer would be a 3, right? So then for me during the contest, what I was trying to think is like, well, what answer gives you a 3? Maybe something like this, right? This is a 3, but then by the same logic, you could just remove the 1 in the middle, and then you would just remove 1, right? So then now I think, well, and to be honest, this, especially during the contest, I couldn't prove this, or maybe there's some if I had infinite time, I would maybe just go over a lot more examples and kind of prove it to myself a little bit as much as I can. But I just wanted to waste it a little bit and go as fast as I can, right? So then for me, I had a conjecture during the contest of, well, I think the max answer will only be 2, right? And and in this case, for example 5, you remove this one. I think they try to trick you a little bit into thinking that, okay, if you remove this one and this one, it'll be good. But also you can, you could just remove this one and this one, right? So I was not sold. So there are a lot of ways to remove 2, and again, some of this is just guesswork, right? So now my conjecture during the contest is that the maximum answer that you can get is 2. Well, what does that give us? And some of this will be competitive programming experience, because normally, like I said on an interview, maybe that's not the way I would go, and I don't know. To be honest, I don't know how I attack it from an interview's point of view. But on competitive, well, your max answer is 2. That means that your base answers will always be 2. So I have a return 2 answer here, right? But what does that mean, right? That means the only thing that you have to check for is 0 and 1. And then now here's where I look at the edge, the constraints of the problem. So given that the rows times columns, it's going to be 900, which is 30 square. The most you can do is 900 square to have a reasonable expectation that it'll finish in time, right? But because of that, that means that, well, 0 case is very easy, right? You just do like I said, connect the components. If everything's connected, then you have to do something else. If it's already more than 1 island, then the answer is 0. So that's basically what I have here. I basically check and this is a straightforward check whether it's an island algorithm. I go through the matrix. I check if there's one. Okay, then and now I try to visit every node. So I do a straightforward recursion, and I visit all the nodes, and I visit as many nodes as I can, going up, down, left, right. If it's disconnected, then I return 0. And then now, because of that, how can you check whether it's 1 or 2? Well, again, I just do brute force. Basically, for each one, I just go, okay. So for this grid, if it is a 1, I go, okay, let's turn this to a 0 and then see if it's disconnected. If we turn it to a 0 and it's disconnected, then it is a 1, right? If you turn it to 0 and it is still connected, then you have to check more. And basically, if there's one case in which you can disconnect this one and XY such that you make it disconnected, then you have 1, and that's all you need. I don't know if I explained it this well. To be honest, it's a really tricky problem, and there's some proofs that I definitely did not do. So maybe it's it's a homework for y'all watching. But basically, that's basically it. I had some issues with backtracking. I just forgot to reset the state, which is dumb for me. And that cost me 5 minutes and like a number of ranks. But basically, yeah. For each node, for the one case, for each node, if it's 1, I turn it to 0. I reset the visit state. I check a neighbor to their first search form, and then if I could visit all of them, or if they're disconnected, then I return 1, because that means that's the node that I removed to disconnect the island. That's all I have for this problem. Well, no, let me go over the complexity, right? So basically, for each node we can disconnect. So we could disconnect each node once, right? And for each of those nodes that we disconnect once, we visit every cell possibly. So in that case, it is n squared, where n is the total number of cell, which is rows times columns square, or rows square times columns square. So that's the time. And in space, it's going to be row times column for visited state. Though you can also, even with the stack space, you're only going to go rows times columns, even in the worst case. So linear time, quadratic time, linear space, and the number of cells. So that's the analysis for this problem I have. Hit the like button, hit the subscribe button, and also I'm going to solve this live for my contest, or you can see me solve it during the contest live right about now. Let's do Q3 first. Well, that means 3 people already finished. Thirty by 30. That's hard, maybe. Let's try it. So the answer has to be less than 4. But then you test for 1 and 2. How fast do you be able to get this farm? Let's see. This is the people got it pretty quickly actually. So 900 times 900 is pretty slow actually. So this is the only answer for 1, I think. Right? And this wants to show that this is 2, but can it even be 4? Because in that case you're just, can it even be 3? So it can be 4 because if it's in that case you would just remove the 1 here and then there's some induction thing maybe. Can you do 3? Okay, I can't prove this one. I need a case, so maybe I'll just spend whatever. It's not quite what I want, but once more visited, then return 1. Now let's return 0 because we don't need to do anything. Okay, and then now man, I'm terrible at this. Now let's try to see if that passes for 3. Okay, that passes for way too much actually. Oh no, this is wrong. This is if 10 times that's already connected. Okay, so this is good. And now let's see if we move 1. This is a weird case though. I have to think about how to handle this. Like, why is 1? I guess there's only 1 island. Here we go. That didn't go as expected. This should be, no, this should be good. Oh, I messed up. Let's see, fingers crossed. Oh, I didn't kick -1. It is true. No, this should. Oh, I don't. Dumb. Hey everybody. Yeah, thanks for watching. This was a fun contest, so yeah, let me know what you think. Hit the like button, the subscribe button, and join me on Discord, and I will see you during the next contest. Bye bye.